Consider the expansion of a given expression. Determine all possible values of n for which the expansion has a non-zero constant term. So let's consider full expansion. It looks like sum for I from 0 to n, combinations I out of n, 8 times x cubed and negative 1 over 2x, and we can write I here and n minus I here, or it can be vice versa, I here and n minus I here. It doesn't matter in general, so let it be I here and n minus I here. And the idea is that since we can see x here, let's simplify it to get finally a single x to raise to some power. And actually you can consider a general term and don't write sigma. So it becomes sum combinations a to the power of I and minus a half to n minus I, and x to the power of 3i, and x is in denominator, hence it's x to negative 1 and to n minus I, and finally it's x to the power I minus n, x I minus n, and x to the power 3i multiplied by x to the power I minus n, it's x to the power of 4i minus n. And we need constant term. Constant term, it's x, the term containing x to the power of 0, and we can get x to the power of 0 when 4i minus n is 0 and I is n over 4. What does it mean? And what is I? I is positive integer from 0 up to n, and n is also positive integer. For example, if we consider n to be equal to 1, I is 1/4 to get x to the power 0, but I cannot be a fraction, and the first possible value of n is 4, so that we get I is 4 over 4. So when n is 4, for I to be equal to 1, we get term containing x to the power of 0. The next possible value of n is 8, so when n is 8, we get constant term for I is 2, and so on. The next possible n is 12, and for n to be equal to 12, for I to be equal to 3, we get constant term. And so in general we can write that n must be a multiple of 4. So solution is n must be 4k, where k is integer and actually positive integer. So it means that k is 1, 2, 3 and so on. When k is 1, n is 4, the first possible power, and so on. So answer is this. And that's all for this question.